Hello friends, this is the next video on recurrence relation, and the type of recurrence relation is a decreasing function. So already I have made one video on recurrence relation. Now this is the second video. See, the title I have given is recurrence relation decreasing function. So 1, 2, 3. So you can see all those functions. So each function is covered in a separate video. Here I have a function, it's a recursive function. When n is passed, it is calling itself for n minus 1. Then inside this, there is a loop, for loop is there. Let us find out what's the time. So for this, I will say this takes Tn time. Then, how much time this loop takes? So I will try to take details. This condition takes 1 unit of time, and this for we have been writing n plus 1, and whatever is there inside will execute for n times. Then what about this statement? This will execute for Tn minus 1 time. Then what is the recurrence relation? If I write this one, then Tn is equals to sum of all these. So Tn is equals to Tn minus 1 plus 2n plus 2. This is what the recurrence relation I got. But if I take it in this form, it will not be easy for me to solve it. So this part of a relation, we have to take a asymptotic notation of that one. Means I should round it up. I should not take 2n plus 2. So what is the notation for that? It is big O of n, or theta of n also I can say. It belongs to a linear class, degree 1. So that I can frame it as Tn is equals to Tn minus 1 plus n. Instead of writing 2n plus 2, I can simply write n. Now this is the recurrence relation I got. Alright, so let us prepare this recurrence relation. See, Tn is equals to Tn minus 1 plus n for n greater than 0, if it is greater than 0. And when n is equals to 0, what it is doing? It is doing nothing. So I can say some constant, or I will call it as 1. So instead of constant, I am writing it as 1. Right? Or you can take C or anything there. So that's it. So here we have learned how to prepare a recurrence relation from a given algorithm or a function. Now this recurrence relation, I will solve it using recursion tree. Tn. It is taking n amount of time. This one, loop, is taking n amount of time. And also it is calling itself Tn minus 1. Then what about this step? See, that is printing n times. So I have not written print here. I am saying that that statement is taking n times. So I wrote just time. I am not tracing it. I am preparing a tree. Now, this will be n minus 1. And again it will call itself n minus 2. Then this will be n minus 2 times this loop will repeat, because now the value passed is n minus 2, and this will be Tn minus 3. Continue. If I continue like this, then where it will stop? This n will reduce by 1 every time, and it reach till 0. Why? Because we know the value of n is equals to 0. When n is equals to 0, answer is 1. So that is the smallest value that we know. So we say that it is reducing up to T2. That time it will print 2 times, and T1. And for T1 it will print, that loop will print for 1 time, and this is T0. For T0 it does nothing. That's it. So what is the amount of time taken here? See, if you compare this one with the previous example in the previous video, you can find that printf was there, so I was printing the value. But no, I am not printing the value. I am saying that this statement will take an amount of time because it is printing n values. Instead of writing all n values, I am just writing time. Now let us find out the time. How much time it is taking in this step? N. Then what about this step? N minus 1 time, and then call. So n minus 1 time, and this call is there. So this call is taking how much time? N minus 2 and then n minus 3. So this will take how much time? N minus 3. So goes on. This will take how much time? 2 and 1, then 0. If I sum up all these things, then it will be 0 plus 1 plus 2 plus, from here I am adding, then goes on to n minus 1 plus n. What is this? N into n plus 1 by 2. So the total time here, see the time for this one is n plus this time. How much is this time? N minus 1 plus this time. So I have added all of them. So the total time is n into n plus 1 by 2. So Tn, we got the answer as n into n plus 1 by 2, and this is n square. Now you write theta, big O, whatever it is n square. So the time taken by this algorithm is n square. This is using tree method. I have solved this, right? So see, by practicing you get the idea. You don't have to elaborate it this much. Quickly you can get the jump onto the answer. So just you need to practice few functions and recurrence relations and get the answer. Then you can directly give the answer. You don't have to solve all these. When you are writing a theory examination where you have to write essay type questions, there you may have to write on all these steps and then prove that it is n square. If it is objective type question, direct answer you need. So there is a method to know the direct answer also. We will be looking at this in coming videos. Now I will show you another method, that is back substitution or induction method. So that is back substitution. By substitution we will solve this one. So I'll remove this and I will solve just recurrence relation. Now let us solve this one. Tn is equals to Tn minus 1 plus n. I can know this one if I can find out this. So what is this? Since Tn is equals to Tn minus 1 plus n, therefore what a Tn minus 1 will be? Tn minus 2 plus n minus 1. Isn't it? See, n in case of n, in place of n minus 1. So in place of n minus 1. Already minus 1 is there. So n minus 2. Then plus in place of n minus 1. Now I know this one. So instead of n minus 1, I can take this and substitute it here. Now this becomes Tn is equals to, what is this? Tn minus 2 plus n minus 1 plus n as it is. If I open the brackets, Tn is equals to Tn minus 2 plus n minus 1 and n. Remember one thing, whenever you are solving this one, don't add, it becomes 2n minus 1. If it becomes 2n minus 1, it will be difficult for you to find out a formula for this one or a single expression for this sequence. Actually, we will be getting a sequence. So based on that sequence, we have to prepare a formula. If you add, you'll be getting just a single one or two terms. So from that, we cannot figure out the formula. So better avoid adding these terms. So If this was the starting equation, now after first substitution, this is the second equation I got. Now further I will substitute. I need to know the value of this. So here only I will continue. So what if I write n as n minus 2? Instead of n, if I write n minus 2, then this will be n minus 3 plus n minus 2. Instead of n, it is n minus 2. Instead of n minus 2, sorry, n minus 1, n minus 2 minus 1. So n minus 3 and this n minus 2 directly. So in place of, in this equation only, the first one only, I have just kept n minus 1 in place of n. So I got this one. So this part, I will substitute it here. So what I get, Tn is equals to, in brackets, Tn minus 3 plus n minus 2 plus outside n minus 1 plus n. Open this one. Tn is equals to Tn minus 3 plus n minus 2 plus n minus 1 plus n. This is the third equation. See, after doing it for 2 times, then you can go to k steps and then you can get the formula. This is the method followed in induction, right? So we are substituting the value. So induction or substitution, whatever you call it. So I have done it for 2 times. Now from this I can observe and say, if I do it for k times, what will happen? See, when first equation it was n minus 1 and n. This was second equation n minus 2 and then n minus 1 and n, 2 terms. Now n minus 3, n minus 2, then 1, then n. If I do it for k times, what happens? I'll use this part. Yes. If I continue this for k times, let us see what I'll get. Tn is equals to Tn minus k. Instead of n minus 3, I am writing n minus k plus n minus 2. This was 3, so it will be 2, 1 less than this one. So if this is k, then this will be n minus k minus 1. This was 3, so that is 2. The next will be n minus k minus 2 and goes on to n minus 1 and n. So this is the fourth one I got, right? This is the fourth one. This is up to k. Now I assume that I have reached till n minus k. So I assume that I have reached till 0. N is 0. So assume n minus k, this one, has become 0. Therefore n is equals to k. Now in place of k, if I substitute n in this one, let us see what I get. Tn is equals to this one, Tn minus n plus n minus, I'll open this. So this becomes minus n plus 1. So instead of k, I am writing n and then I am opening the bracket plus n minus n plus 2. Then goes on, last terms will be n minus 1 plus n. These 2 last terms as it is, there is no k here. Now simplify it further. Tn is equals to T0 plus this nn gets cancelled, 1 plus nn gets cancelled, 2. So it means I can figure out the next term is a 3. Yes, it is a 3. Then goes on up to what? N minus 1 plus n. That's it. So what is this I got? What is this I got? This is sum of first n natural numbers. Then Tn is equals to T0 is what? 1 plus this is n into n plus 1 by 2. That's it. If you compare the tree method, there also I got n into n plus 1 by 2. But here I got one extra because this is giving me calls, number of calls actually. So plus 1 call extra. Anyway, almost it is same thing. So what is this? This is theta of n square. Theta of n square. That's it. I have solved this second one by using recursive tree method as well as by substitution method, and we got the same answer. It's order of n square. So in this video we have learned how to write a recurrence relation for any algorithm or a function, then how to solve that recurrence relation to get the answer. So we saw two different methods for solving it. This is useful for understanding the procedure how to solve it, and also useful for that is theory exams. Right? But for objective type questions, you should know directly how to get the answer. That will be learning in next videos.